Okay, let's look at the 6.3 problems. Again, a lot of people ask, how do I know what formula to use? Let's look at this problem. This is the way, what formula to use. They give us the average life, they give us the x bar, okay? They tell us the standard deviation, or sigma. But notice what else do they give us? A random sample of 100 balls. They give us an n. And in the case of n, that's a different formula. So it says, what is the probability the sample mean will be less than 295, the default? So this is using the formula x minus x bar all over sigma divided by the square root of n. How do you know? You're going to have an extra number here. They're going to give you a sample size. That's how you're going to know. So I go ahead and I plug everything in, 295 minus 300 all over 25 over the square root of 100. Stick that in the calculator. You get -2 for your z. This is, sorry, z equals. Look up -2 in your book. This is the area that corresponds to it. Now the next one is saying, in which of the following situations is the central limit theorem not applicable? Okay? Notice here, our sample size was 100, all right? It was over 30. That's a big part of this thing, okay? The other thing is, if they don't give us a sample size, or if they tell us it's a small sample size, as long as they say it is normal, if they use the words normal, normally distributed, it is normal, then we can go ahead and do this stuff forward, okay? If they give us a situation when the sample is small, below 30, and not normal, it's a no-go, okay? Everything else is okay. We can do that. So please be aware of that situation. Your teacher's going to give you one like that, but they might ask you the definition. Okay, continuing on, let's look at this one. It says here, the average number of gallons consumed by the football team is 20, x bar, with a standard deviation of 3, sigma. Assume it's normally distributed, okay? When a game is played, find the probability of between 20 and 25 gallons. So again, they don't give us a number, but they tell us it's distributed normally, okay? So between 20 and 25, I need to find both. So 20 minus 20, because that is the mean, all over 3. And then I'm going to have 25 minus 20 all over 3. Well, this gives me 0, so z is equal to 0. When I look that up in the book, that's 0.5. This one will give me 1.67. When I look that up, I end up with 0.9525. Go ahead and subtract these two. 9525 minus 0.5, and I should end up with 4525. The next one says less than 19 gallons. Well, I need to find 19 minus 20 all over 3 gives me -0.33. It does matter what order you subtract in, otherwise these will be wrong, so please get that correct. And it's always your test x minus your mean, always. Then it says here, suppose you consider a random sample of 10 games. What is the probability the sample mean will be more than 21 gallons? They already told us that it was normal, so if we're going to use a sample of 10, we're good, which is less than 30, okay? So again, I need that other formula that we just had. 21 minus 20 over 3, just stick it on this square root of 10. Pop that in the calculator, and I get 1.05. Now, it says here more than. I look up 105 in the book, and I get 0.8531. That's not the right answer. More than is another way to say 1 minus. It means to the right. Please know that. So I do 1 minus 0.8531. That ends up giving me number A, or letter A, sorry. Now, scroll on down, it says here, random sample of 12 games, that's my n, was a probability between 21 and 22. So, 22 minus 20 all over 3 divided by the square root of 12, and 21 minus 20 all over 3 divided by the square root of 12. Pop this in, pop that in. This one, I get 2.31 for z. Here I get 1.15. Look them up. This is 0.9896. This is 0.8749. Subtract them. Put a minus there for that. I end up with 1147. Okay. Now, last but not least for this section is number 4. So So going ahead and doing this, says the average water bill, is 72 x bar, standard deviation, sigma is 6. Normally distributed, 15 is my n, less than 75, that's my test. 75 minus 72, all over 6, all over the square root of 15. Punch that in, you get 1.94. Because they said less than, whatever that is in the back of the book, is the answer, which is that one. Now, I have section 7.1, and I can go ahead and do the first one before cutting this off. Timeline. Okay. Oh, right here. I've had it right in my hands the whole time. Okay, now look at this. Okay? Couple things with this problem we need to keep in mind. They do not give us the mean. They give us sigma, they give us a standard deviation. I am missing x bar, and the next question is about the mean. If you have a graphing calculator, okay, you have a TI 83 or 84, you can go ahead and punch these numbers in the calculator under a couple things. If you go, I'm going to write it down here so you'll see exactly what I'm talking about. You might know this from section chapter 3. So if you click on stat, you go to edit. They give you a table. You have like L1 and L2. And maybe even L3. Make sure these are just clear, okay? Enter in all these numbers at the top, all these right here, into your L1. And you hit enter after like every one of them. So like the first one's 211, and then you just keep going, okay? You're done. Go back to stat, go over to calc, and then click on one variable stat. Whenever you do that, it will tell you n equals, so please double check that that n equals is the same as the n in the problem, because if you missed one and you type one in, you type one in like twice or something, you're going to have a problem. Then it says n is equal to 32. They'll give you x bar, and they'll also give you s of x and sigma of x. Now, it really depends on the problem that you're doing which one you want. In all of these, you want sigma of x, except for whenever you're doing the t stuff. We'll get to that in a little bit, okay? So, I'm just telling you how to do that. So, I already went ahead and did that. And I got the answer, because I'm not doing this by hand, no siree. So, I went ahead and did this in the calculator, and I ended up with my sample mean, my x bar, is 346.3. You do have to round it, okay? And so that, answering this one, is B. Now they're asking about the confidence interval. Because they're asking a confidence interval, the formula for this is this guy right here. X bar minus Z alpha over 2 sigma square root of n is in between mu, that's that little U looking character. The same thing plus instead of a minus. Same exact thing, except it's a plus instead of a minus, okay? So, you're going to have two answers here, just like that. Now, they say a 92% confidence interval. In your book, in the back, on the T-chart. So if you look on the T-chart, okay? At the very bottom, they give you the Z's. They give you the Z values for an 80, 90, 95, and 98, and 99% confidence interval. If they give you any of those in the problem, you can just go ahead and get the answer, and that's what you don't have to find. In this case, 92 is not there, so you have to find it. As far as I heard, you don't have to do one of these on the test, so you really don't have to pay attention to this part, okay? Alright, let's go ahead and do it. So how would you do it, hypothetically, if you had to, okay? Is you do 1 minus alpha, so like a couple step process. So 1 minus 0.92, you make that a decimal, you get 0.08, divided by 2. Notice in the formula, they have alpha over 2. So divided by 2, you get 0.04, alright? Now you gotta go back again and do 1 minus 0.04, and you get 0.96. Look up the z value that goes along with this, and you get z is equal to 1.75. That's the z for this problem, which you're gonna plug in right there. So now that I have that, I have everything for my formula to do this. My x bar is 346.3 minus my z is 175. My sigma they gave me in the problem, 165.1, all over the square root of 32, that's my n, is in between mu, and then I have the same thing except it's a plus. I punch all this mess into the calculator, and I get 295.2. Now, if you have a graphing calculator, if you hit second, whenever you get your answer, the 295.2, and then you hit enter, you'll notice above in blue it says entry. So what it does is it repeats this entire thing here, and the only thing you need to go in is change it to a plus sign. And so then it just spits out the next answer, and you don't have to retype all that mess all over again and make a mistake. 397, which is letter D. So, kind of complicated. If you don't have a graphing calculator, I feel sorry for you. Please borrow one and know how to use it before you go into this test. And then I'll move on to the next question, which is very similar whenever I